So, good evening, everyone. Welcome to the live session of. Uh, is my sound okay? Yeah, hello. So, yeah, yeah. So, sorry for the disturbance. Hello. So, yeah. So, is it audible and the screen is visible clearly? Yeah, yeah. Thank you. Thank you for the response. Yeah. So, welcome to the first live session of Fundamentals of Additive Manufacturing Technology. So, as this is a sort of problem solving session, which are where we will be discussing questions on numericals similar to the assignment problems, which usually come in every week. So, today we'll be discussing the first week's assignment, similar M assignment questions, not the exact assignment questions where so this is an activity which is being done so that it will be easy for all of us to score well in the assignments, regular weekly assignments. So in this first week we'll be discussing on the introduction of additive manufacturing technology and the CAD models, a brief introduction to CAD models. So here we'll be discussing around 10 questions, concepts behind those questions, and after I give the questions, it will be really very good if all of you just try to solve the questions and answer it along with me, so that this will be like interactive session for all of us. And this session will be held twice, once Friday and once on Tuesday, 7 to 8 p.m. regularly for the coming 12 weeks. Okay, so if anyone has any questions, please you can go ahead. Okay, so let's start with the session. Okay, so the first question is the intersection between the horizontal planes and triangles are represented by which of the following? CAD file, sliced file, STL file. So I am assuming all of you would have gone through the videos and going through the videos will help you in solving the questions. So, so the intersection, yeah, if you know the answer or anything similar, you can type in the chat box. Okay. Okay, I'll just be discussing that thing, whatever you said. But okay, you can, whoever wants to, like, if you know the answer, please type in the chat box so that it will be easy for all of us. So this, okay. So the intersection between the horizontal planes and triangles are represented. The correct answer is the sliced file. Okay.
Excuse me, ma'am. Ma'am, you are not audible. Hello. Only noise is coming, ma'am. You are not audible.
Hello, is it audible now?
Yes, ma'am. Yeah.
Okay, okay, thank you, thank you. Okay, so let's proceed. So in STL file, the surface of CAD model is represented by triangles, as we can see here. While in the sliced file, there we see there is interaction between the horizontal and plane and triangles. And the CAD file is the file which we usually get from the SolidWorks or any processing software. So this is the difference. That is why the correct answer is the sliced file. Okay. Um, Also in this would like to say some discuss about like when the material is deposited there onto the edges. So two forces will occur. So that first will be the downward gravitational force, and the second will be the due to the surface tension of the material. It will be so. So why this discussion comes here is that in this slicing we will have to give support. If the overhang failure is large, then suppose the droplet will roll down. Gravitational force will be higher than the surface tension force. So in such case, we need the support mechanism. So while slicing, the file, a support mechanism is very essential. Okay, so this is the first question answer, which is the correct answer is sliced file. Okay, so moving on to the next question. Which of the following methods are included via additive manufacturing? So as we know from the videos that there are 7 methods of additive manufacturing, which has been clearly mentioned. So out of this, first one is the 3D printing method. Second one is the laminate object manufacturing. Third is the fused deposition modeling. And the last one is the, okay, someone has answered FDM. Okay. Any more answers? I'll just write LOM is laminate object manufacturing, and 3DP is 3D printing, as we know. Okay, so VAM, somewhere is the correct answer is C and D. That is FDM and wire arc additive manufacturing. So as we see in the like this classification is based on the raw material, where the raw stock is divided into liquid, solid, and gas. When we have this liquid, can be done through SLA and rapid freezing. The solid can be done in 3 forms: sheet, powder, and wire. And in the wire additive manufacturing, we have this fused deposition modeling and wire arc additive manufacturing. Also in the options, there was laminate object manufacturing. So I want to discuss a brief about laminate object manufacturing. This is here, the layer are in sheets. So layer layer of sheets are there, and this is a hybrid in nature. These layer of sheets are joined together by pressure and thermal activity. The laser comes and cuts the sheets, and this process is called as layer object manufacturing. Apart from this, we also have, as we have already seen in the videos, that there is direct energy deposition, selective laser sintering, and various this direct energy, which is the based on powder raw stock. So FDM is the fused deposition modeling and fire arc additive manufacturing. Okay, there are some responses. Yeah. So some people have answered it correctly. Okay. Okay. So okay. So moving on to the next question.
Sheet this for binding also some binding material is also required with accept only pressing will not do.
Yes, not pressing. Actually, the thing is we need pressure and heat, thermal activity for this layer of sheets binding in by pressure and thermal activity both.
But some binding material is not required.
It depends. It depends on the material.
Okay, ma'am.
Oh, is it clear? See, the details of all these methods we will be discussing in the coming coming weeks. So we can go through it very deeply at that time. But uh, okay, so sheet laminations. So since there are someone asked, so what is this? But there is a material spool, and from the material spool, the hatched material that will go to the build platform, and from the a motorized mirror laser will come, and this will hit the hatched material which is on the build platform, and where this material is on the build platform, their pressure and temperature is there, through which the sheets will be laminated. So this is the just the overall gist of the sheet lamination method. Okay. And also, if we go through as there are 7 basic additive manufacturing processes, so lamination is bit towards higher energy consumption. Powder bed fusion is also towards higher bit energy consumption. Um, okay. So this is all about this question. Coming to the next question. Which of the following represents the rapid prototyping method? So as we know already that there are 2 types, physical and virtual prototyping. So virtual prototyping is it is satisfied by computers and physical or also rapid, we can say that it is satisfied by the additive manufacturing, and it is carried out in a very fast manner. So I'll just explain this first. Prototypes. These are maybe of virtual and physical. It is also known as rapid in some cases. Okay. So here the definition of product, concept, design and evaluation, design analysis. This much is always virtual. And next is prototype, 3D, CAD model, and sorry, is the screen not visible?
Yes, madam. Screen is not
Yeah,
visible,
yeah,
madam.
yeah, yeah, yeah. Just reshared it. And design documentation. These. Okay, so the answer is B and D, which comes to that design analysis and available object. So we'll just understand this. See, virtual prototyping, as we can see, I also wrote this. Definition of product, concept design and evaluation, design analysis. These three come under virtual prototyping. While prototype and the 3D CAD model and design documentation, this comes under rapid prototyping. So I just want to explain a small thing over here. This is the flow chart for virtual prototyping and rapid prototyping. So what is the difference? Like when you, if we go for an example with a graph, consider this as virtual and this as physical. Okay, and we will here go from rough. This is rough, accurate, and this is a complete. This is also component. Okay, so when we have like a sketch, suppose we have virtual, rough and complete. Virtual, rough and complete. So this we can give an example of virtual, rough and complete. This is example of sketch of a car, and this is a virtual prototyping. When we have an example of accurate, complete, and virtual, accurate, complete. This is an example for also virtual prototyping, and this is where we can say CAD model of a car. And next is for physical, rough and complete. Physical, rough, complete. This we can term as a prototype of a car. Prototype of a car can be said as physical, rough and complete. And this is, so according to the options, we have design analysis where the prototype, 3D CAD model and documentation. This is for rapid prototyping, and available object RE3D geometry model. This is wrong. This first and A and C both are virtual prototyping methods. I hope this is clear, the difference between a physical and virtual prototyping. Virtual is basically the concept design and evaluation, and rapid is where we convert it into products. This is the generic classification. Okay, so let's move on to the next question. Which one of the following represents a valid solid model? Okay, so the correct option is B. Well, we know that solid models, there are 3 points which define a solid model. One is complete, valid, and unambiguous representation of the object. So, what is a complete solid? Complete solid is one which enables a point in space to be classified relative to the object, if it is outside, inside, or on the object. So, according to the question, the valid solid model is being asked, which is that it does not have a dangling edges or faces. Like it should be a complete. There are no extra, whatever it is. An object should be complete. There should be no extra like this or extra dangling edges or faces. An ambiguous solid only has one interpretation. These are the three criteria required to fulfill a solid model. So according to the question, which one is the valid solid model? The correct option is B. Okay. So moving on to the next question. The additive manufacturing technology is dependent on object geometry. Is it true? The statement is true or false? Yes. Yes, the correct option is false. Correct option is false. Okay. So why it is like this? Suppose if we have a cylinder and this is the hole inside that. Another, so, and let us consider, so this is another cylinder. I'm just taking the top surface and the hole is bigger. So this is the area outside. So if the hole is the larger, in the whole larger hole, the hole will be bigger and the side region will change. So this technology is independent of object geometry. See what is here done is here layer by layer, layer by layer, layer by layer, layer by layer. Uh, so here layer by layer manufacturing or slicing of layers is done, which is done layer by layer. So when the hole is larger, the side region will change, but this will not affect the this addition of layer by layer material on the surface. So that is why this additive manufacturing process is completely independent of the object geometry. Okay, so next let's now move on to the numerical part. So now we will be understanding on the mathematical equation of a triangular surface. So, uh, so the question is we have to find out the mathematical equation of a triangular surface. So I'll just write out the steps on how to do it. Step 1. Step 1 is find out whether the points are collinear by checking the determinant. If determinant is not equal to 0, points are not collinear. Step 2 is put the vertices of the triangle x1, y1, z1, x2, y2, z2, x3, y3, z3 in the equation of the triangular surface, which is x minus x1, y minus y1, z minus z1, x2 minus x1, y2 minus y1, z2 minus z1, x3 minus x1, y3 minus y1, z3 minus z1 is equal to 0. This is the equation of the triangular surface. Suppose let's draw the axis. These are the x, y, z, and these are the vertices of the triangle which we already mentioned: x2, y2, z2, x3, y3, z3, x1, y1, z1. Okay, so suppose let's consider these points as now x1, y1, z1 as 1, 1, 0, 1, 2, 1, and here it is as -2, 2, -1. So when we substitute in this x minus 1, y minus 1, z 0, 1, 1, -3, 1, -1 equal to 0, then after solving in this equation we will get it as 2x plus 3y minus 3z is equal to 5. So for these particular vertices, this will be the mathematical equation of the triangular surface. Okay, so in this way, this is the approach to solve. Um, so you need to, so as the x1, y1, z1, z, x2, y2, z2, x3, y3, z3 would change, the surface equation will change according to that. I hope it is clear to all. So let's move on to the next question. Okay. So next one is how to find out contact normal of a triangle. So so let me draw the graph first. Question is how we are now solving how to find out the contact normal of a triangle. So these are the co-axes x, y, and z. We will stick with y nomenclature. So this is the word. We'll now draw the triangle. Yes, the uh, whatever was written in the chat box, the response was correct. But we will just see elaborately how to solve it for a numerical question. Consider a point P1, P2, P3. Okay, so these are the coordinates x1, y1, z1, x2, y2, z2, x3, y3, z3. So here we have we are defining a vector. Now we will define a vector. Now this is a vector. A vector connecting P1 and P2. So this will be over here. And the contact normal, as already said by someone, it is the n cap, outward contact number. And here we will consider it as counterclockwise. So A vector will be connecting P1 and P2. B vector, this will be connecting P3 and P2. This will be B vector. So now we will write the equation x2 minus x1 I cap plus y2 minus y1 j cap plus z2 minus z1 k cap. For B vector it will be x3 minus x2 I cap plus y3 minus y2 j cap plus z3 minus z2 k cap. Now, as we know, n cap is equal to A cross B by A cross B magnitude of A cross B. N cap is the unit vector in outward direction. So A cross B will be find out normally by the cross, how the way we find out the cross product. I cap, j cap, k cap. This will be x2 minus x1, y2 minus y1, z2 minus z1, x3 minus x2, y3 minus y2, z3 minus z2. And subsequently you can also find out the magnitude. And in this way, by solving further, by solving, find out the magnitude, and you will get the n cap. So whatever be the equation, vertices in the question, you will be given the vertices of the triangle x1 y1 z1, x2 y2 z2, and x3 y3 z3. According to that, you will be finding out the contact normal of the triangle. This is the complete procedure. Okay, so moving on to the next question. So this is, as we know that the STL file, this can be this has two formats, ACIA format and the binary format. So this is the question based on the ACIA format. Yes, direction is very much important for taking the points, because according to that, A vector, it is like the previous question. A vector, this connects P1 and P2. Again, this B vector connects P2 and P3. So whenever you are going solving any questions numericals, the directions are very, as this will represent I cap, j cap, k cap. And also we are finding out the cross product. Okay, so coming back to the question. So here, uh, we have to show in the given triangle of an STL file, show that the facet normal data is redundant. So first is, as we know, we have in various, this is the STL file in the ACIA format. There is another format which is the binary format. So Now, I hope all are familiar like what is the ACIA format, but still I'll show this. Suppose let us consider this as a uh, representation of a solid sphere in ACIA format. The first one is the name of the file, and this line is the unit vector in the direction of the facet normal. So question is asked that, and these three, the vertices in the coordinates which we have already defined in the ACI format, these are written in this within the outer loop and the end loop as this. This is x1, this is x1, y1, z1, x2, y2, z2, similarly x3, y3, z3. So these group of three vertices, these define the triangle vertices, and these are between the outer loop and the lower loop. So what we here want to say that eventually that this giving this we want to show that this facet normal, unit vector normal, is redundant. That means that even by using the right hand rule, we can find the direction to the facet normal. So initially giving this in the ASA format, we have to show that how it is redundant. So the process for this is like this. So consider, so we will now first write out the coordinates. X1 is equal to 320, Y1 is equal to 100, and this is 0. Z1 is equal to 0. Similarly, X2 is equal to 320, Y2 is equal to 0, and Z2 is equal to 300. X3 is equal to 320, Y3 is equal to 0, Z3 is equal to 0. Now, as discussed previously, we will take out the cross product. A cross B is equal to I cap, J cap, K cap, X2 minus X1, Y2 minus Y1, Z2 minus Z1, X3 minus X2, Y3 minus Y2, Z3 minus Z2. So, putting the values in the formula, we get I cap, J cap, K cap, 0 minus 100, and this will come as 300. This is 0 minus 300. On solving this, we will get 30,000 I cap plus 0 J cap plus 0 K cap, and the magnitude of A cross B will come 30,000. Now N cap is equal to A cross B by A cross B magnitude. This will be 30,000 I cap by 30,000. This will be I cap, which comes to 100. And now when we check this with the facet normal, this will be 100. Check with the facet normal, which is 100. So facet normal information is redundant. This is the procedure for showing how the facet normal information is redundant. Uh, okay. So I think if all have noted down or are okay with the question, we'll move on to the next question. Okay, next is we will write a ASCII code for representing the cube of a side 1 unit. I'll draw the cube first. We have to show the this side. Now I will put the axis. This will be y, x and z. X. Okay. So we'll just now put the coordinates 0, 0, 0. This will be 0, 1, 0. This will be 0, 1, 1. This will be 1, 1, 1. This will be 1, 1, 0. Now so here we'll write the facet normal first. So why it is minus 1? Since it is towards this direction, so it will be minus 1, 0, 0. This is the only trick involving this question. And next is, so here if you must be able to give the coordinates properly. If you are able to give the coordinates properly, so you can easily write this ACI code. Since this plane is in this direction of y, so it will be, the facet normal will be minus 1, 0, 0. So, and rest is, you just need to write down the vertices of the triangle, which is simple and straightforward. Vertex x1, y1, z1, x2, y2, z2, x3, y3, z3. And this is the end loop. This is the format in which we write the ACI code. So suppose now if we come across a question where and we since we are considering this in the counter clockwise direction, so we have taken this as minus 1. Suppose in a question we are given to represent the side of a cube. If suppose in the question we are given in this plane, I'm not drawing it again, I'm just showing it in this plane, then the facet normal for that question will be, here it will be, for this plane it will be 0, minus 1, 0.0, 0.0. This will be a difference. So whichever will be the axis, according to that, seeing the direction and counterclock, since it is a counterclockwise direction, we give the distance of the facet movement. Moving on to the next question. How many triangles will be yeah, please. Sorry, your voice is not. Can you please repeat? Yes, 0, -1, 0. This is for this plane when we are considering this side of unit. This one. Yes. Okay. Yes. Yeah. You will be changing that. Yes. Yeah. The vertex will be. Hello. Yeah. Yes. Yeah. Correct. Yeah, I didn't change it. Sorry. This I just wanted to represent that how it changes with when you change this side of one unit. Yes. Yeah. The vertex will be 100. Yeah, the see the vertices will change according to that. I didn't draw it completely, so for avoiding the confusion, I'll just make the cube again. 1 second. So now we are considering this plane. So here it will be so here I'll just draw a part of a cube. Okay, so we know for each triangle, as we must have seen in the videos, for each triangle it will be, suppose this is a cube. Okay, just imagine this as a cube. So okay, this is the part of a cube. So for each triangle here we will be dissecting it to one more triangle. So there will, this is a rule, there will be two triangles. I have just written short form, two triangles corresponding to one triangle on top. So these two triangles, now for these two triangles, these have 0-degree angle between them. Okay, so but again there is another close triangle besides this triangle. We have one more triangle, but this triangle won't be having, will have different facet angle, normal. So facet angle of this triangle, this particular triangle, will be represented by a line connecting the center of the above triangle. So this is a, okay, this is the center of the first triangle, and this is the outward normal for this. Okay, and this is the center of this triangle, and which will have outward normal for this. So I will just write it for a clear mention. Facet normal of this triangle will be represented by a line connecting the center of the above triangle. But so difference, what's the major difference is, when these adjacent triangles, these don't have any angle uh, between them. Okay, that is 0 degree. These triangles will be having 0 degree angle between them. I just write it. These two triangles will have 0 degree angle between them. But these two will be having different angle between them. So now rule is, there are, as we know, this is the common rule, that there are n triangles available on the top surface, and each angle is equal to 360 degree pi. Consider n triangles available on the top surface, and rule is angle is equal to 360 degree pi by n. So as per the question which is written, the how many triangles will be required for angle tolerance to be 1 degree. So when we want the angle tolerance to be 1 degree, so it is like 360 degree by n is equal to 1. So n is equal to 360. So this means 360 triangles are required on the top. Similarly, 360 more triangles required on the bottom, and on the periphery, since on the each periphery, see, for this complete section, one here 360, 360, 360, and bottom 360. So on the periphery we have 2 into 360, that is 720. Bottom, top 720. So total n is equal to 4 into 360 is equal to 1440. So in this way we solve the question. So here the major thing you have to remember is, just beneath one triangle there will be always two triangles corresponding to one triangle on the top, and these two triangles will have 0 degree angle between them. But the adjacent one will never have a 0 degree angle between them. This will always have a different facet angle between with the facet normal. So facet normal of this triangle will be represented by a line connecting the center of the above triangle. So with this way we find out the, like, next is, suppose since it is in the question, it is required that one degree tolerance is required, angle tolerance. So 1 is equal to 360 by n. With this, we find out that n is equal to 360, and similarly for all the surfaces we calculate, and finally we get it as the total number of the triangles. Okay, so this is what we have for today's session. So if any doubts are still there, we can again discuss all these questions in the coming classes. Uh, Also, you can also go through your assignments, and if you're in the coming class after submission, we can again discuss it thoroughly if anyone has further doubts. So, is it clear to all of you? So, okay, question 3. Yeah, virtual prototyping and rapid prototyping. Yes, please. Yes. No, we usually say additive manufacturing is equal to a rapid prototyping. Since, like I said, virtual prototyping, it is only satisfied by the computers, but rapid prototyping or additive, which is satisfied by additive manufacturing. Since here we can do rapidly mass production in a fast manner. The job is carried out in a very fast manner. So it is physical, yes, physical. One second, like I'm not a professor, so please, it's just we are like we are some a course team member for this session. Yeah, yeah. Please continue. Which FD? Hello. See, FDM is fuse deposition modeling. Fuse deposition modeling is additive manufacturing, and additive manufacturing is on a larger scale. Sometimes we relate it as a rapid prototyping because, since as you know, the rapid prototyping method, we as we can see, the 3D geometry is converted into the available object. This is what is rapid prototyping. So it is said to be as a rapid prototyping method. And rapid prototyping is also additive manufacturing. So you can say it is both. Hmm. Patch antenna with 3D. Can you give me address? Okay. Um, I will surely have this answer in the next class. I'm not sure, but I don't know which location you are. There is a next gen facility in Chennai, so you can, I don't know, you can just try their next gen facilities. Okay, Guwahati. I'm not sure about Guwahati, but yes, in Chennai there are many facilities. Out of this, next gen is one which I know. Yes, please. Okay. Okay. Actually, I couldn't get your question. Rotational translation matrix, is it regarding some numerical, and or like you are asking for that codes?